Please write this question. Okay, I think we have a new student. Assalamu alaikum, Samiha. Can you hear me?
Yes, sir. Walaikum assalam.
आपका सैटरडे के दिन शायद शेड्यूल किया था ना एक ट्रायल क्लास नहीं? Yes, Samiha.
I don't think so.
You don't think so? So maybe your father would have got the message for that. Okay.
Yeah, I'll ask him.
Okay. So आप कहीं पढ़ रहे थे पहले, right? What are the chapters done? Tell me.
This one and the alcohols, phenols, and
Haloalkane,
solutions in electrochemistry.
alcohol phenols. Solutions आपका हो चुका है, electrochemistry हो चुका है, and
Yeah. And the chemical kinetics.
chemical kinetics हो गया.
Yes, sir. That's
ये चैप्टर पढ़े हुए हैं आपने?
yes.
ओके. तो फिर यही बात सही है आपके लिए. तो अल्कोहल्स, हालोअल्केन, अभी तो वैसे हम अल्कोहल फिनॉल सीधे स्टार्ट करेंगे. ओके. सॉल्यूशन इलेक्ट्रोकेमिस्ट्री एंड केमिकल काइनेटिक्स आर डन. ओके, फाइन. वैसे where do you have more problem in? Tell me.
I think it's more of the remembering part.
अच्छा, वैसे कंसेप्चुअल आपको कहीं पे क्लैरिटी की जरूरत नहीं है. So please try these questions also, है ना? 1 through 5.
Yes, sir.
And which school are you in?
Indian school, Salala.
Indian school, Al-Ala.
Salala.
Salala. You're from Oman, right?
Yes, sir.
अच्छा, और आप सारा की क्या लगती हैं?
We're cousins.
अच्छा, cousins. And you have a CBSE board or some other board, Samiha?
It's CBSE only.
CBSE. Also, like Samia, you can send the answers to me. WhatsApp. This is my number. Okay. Others, you also please send the answers once you're done. Sarah, so first one is correct. Second one correct. Third one is correct. Very good. Yes. So fifth one, please rethink, Sarah, for the fifth one. I think you will get it if you retry it. First one is correct. Second one is correct. अरे नहीं, थर्ड वन में you make both the products ना? आप एक एक प्रोडक्ट क्यों बना रहे हैं, फातिमा? There will be two products, right? In the fourth one,
Yes,
ortho and paradirecting, right? You make both the products.
Yeah.
Okay. For the fifth one, the first answer is wrong. कुछ वहाँ पे आपने extra लिख दिया है. Please see what is that. First is wrong. Second आपका सही है. Second product जो आपने बनाया ना पैरा पे, वो सही है. Yeah, now it is correct, Sarah. You understood it, now? What was wrong?
Yes, sir.
Waiting for Razan, Wafia, Ahmed. Please send the answers, guys. And Samiha, whatever you have done, please send it.
Yes, sir.
Okay, wait a second. Fatima, looking at your answer once again. Yeah, now it is correct, Fatima. SOCl2 वाले में एक ही प्रोडक्ट होगा फातिमा, वहाँ मतलब दोनों प्रोडक्ट वैसे नहीं, आपने गलत लिखा है वो उसमें, तो SOCl2 वाला आपका गलत कर दिया आपने उसको। Ahmed, looking at your answer, A is correct, B is correct, C is correct, D आपने नहीं किया, fifth one सही है, fifth one अभी सही है। Wafia, looking at your answers now, first is correct, second is correct. Wafia, can you please turn your mic on?
Yes, sir.
अरे भाई बेंजीन है ना, इट इज बेंजीन राइट, आप ये कैसे मिस कर दीजिएगा?
Sorry, sir.
Marks like वो हमको सभी बंद में कुछ होगा, like you write it maybe sometime somewhere, I forget the benzene ring, I forget the benzene ring, something like that. But that is correct, your answer is correct, and the fourth one is fine. Fifth one, yeah, very good, correct. Fifth one is also correct. Razan, looking at your answer now, A is correct, B is correct, C is correct. These you have not written anything in the D. E is correct. Most of you guys are having problem in the D. It is Friedel-Crafts. Sorry, it is, yeah, E is Friedel-Crafts alkylation. The fourth one here is halogenation. Samiha, can you please send me whatever you have done?
Yes, I'm just sending it.
Okay. Here we are going to get Cn. Here we are going to get Br because anti-Markovnikov in the presence of peroxide. For this OH will not undergo any change because there is partial double bond, and it is what? It is phenol, and this is an alcohol because it is connected to sp3 carbon. So this OH will be converted to Cl in the presence of SOCl2. Now here we are going to get two products. Ortho substitution will be there, and para substitution will be there. Here also we are going to get two products, and the connectivity will be from this carbon atom. Oh, Samiha, you are not very much comfortable with the bond line structures.
No, not actually.
Okay. I'm sending you a PDF. इसको भेजा था हमने recently. Fatima, have I shared with you bond line? Yeah, we have that. Okay. Okay. So, Samiha, आप देखिएगा, I have shared with you one PDF. Okay. So please go through that PDF. You will understand the bond line structures, because if you know the bond line structure, it is going to help you a lot. First reason is that if I'm going to write propane, for example, CH3, CH2, CH3, it took me for a while. But if I am drawing in the bond line structure, it is just this. Okay. So the number of questions that you can practice in a very small amount of time, it will get exponentially high. Okay. So please practice the bond line structures. Please practice the bond line structures. In that
Okay, sir.
PDF, if you do it, then it will be fine only. Okay. Now, today we are going to learn about optical isomers. Okay. There's a small portion which is optical isomers. Please write optical isomer. Now, so what is the definition of isomer, by the way? Can anyone tell me? What do you guys understand by isomer? What is isomer? Isomer is anything which has, I mean, always. Now, isomer can एक रिश्ता होता है isomer. Okay, A is an isomer of B. B is an isomer of C. So if you have two compounds which have same molecular formula, but they will have difference in properties, but different physical property. ठीक है? Same molecular formula but different physical property. That means this difference in physical properties makes it different. For example, if you have something like this, CH double bond CH. Now this is a cis isomer, right? And then you have CH double bond CH, and you have a trans isomer. Now in cis isomer, you can see that here we'll be having delta negative, and here we'll be having delta positive and delta positive. Now the dipole moment will be something like this for the cis isomer. But if you look at for the trans isomer, you can see that the dipole moment is going to get cancelled because they are in the opposite direction. So for this, the mu net is equal to 0. For this, the mu net is greater than 0. There is some dipole moment, and that is why the cis isomers, they generally have more boiling point than the trans isomers. Okay, they have more boiling point than the trans isomers. Now that is very important here. That means the physical property is going to be different. Now, what are the optical isomers? Please write what are optical isomers. What is the physical property that is different? The isomer which rotates the plane polarized light also known as PPL in clockwise or anti-clockwise direction is called optical isomer. Okay, so generally the lights that we have, they are unpolarized. That means they can rotate in all the direction like this. ये रोटेट नहीं होगा. Now there are various things which can polarize it. For example, जैसे आपके पास जो sunglasses होते हैं ना, so those also they have some ability to polarize the light. That is why certain frequency of light, or we can say the lights in certain direction, they just pass through it, and the others are reflected away. है ना, जो आपको वो pass नहीं करने देता है. So generally we use a Nicol prism for that, and we denote Nicol prism in this manner. We have a rectangle, and then there is a slanting line like this. This is the representation for Nicol prism. What is the use of Nicol prism? It polarizes the light. Nicol prism. This polarizes the light into one plane. So we have different, we have light in different direction. What it is going to do, it is going to give you a light in a single direction. Okay, so let us suppose this vertical line gets passed through the Nicol prism. Now, once we have this plane polarized light, this is my plane polarized light. When this plane polarized light, that is PPL, it is passed through the solution of an optical isomer, an optically active compound. We have a solution here. Okay, this is organic solution. What is going to happen? The light will either rotate clockwise. It was initially in this position. Okay, it has rotated theta degree clockwise, or it can rotate anti-clockwise also. Some theta degree anti-clockwise. Okay, so now when it rotates in the clockwise direction, it is known as dextro-rotatory. This organic solvent will be known as dextro-rotatory. Or it is also known as the D form, or it is also known as the plus form. If it is rotating in the anti-clockwise direction, then it is known as levorotatory. Also known as L form. And here it is known as the negative form. Done, everyone? All of you wrote
Yes,
this?
sir.
Okay. Now right next, that is asymmetric carbon.
So could you scroll up 1 second?
Yeah, sure.
Yeah, done.
Right next, asymmetric carbon. Now please write the carbon which has four different groups. Four different groups attached are called, or is called, asymmetric carbon. These are just definitions, like it will get assembled one place. Okay, just remember these definitions right now. Right next, that is chiral carbon, or chiral molecule. Chiral molecule. Please write the molecule which is not superimposable. The molecule which is not superimposable on its mirror image is called chiral molecule. It's called chiral molecule. For example, if you look at the letter A, and I draw its mirror image. Okay. So for drawing the mirror image, I'm just copying it, pasting it, and rotating it horizontally, right? This will be the mirror image. As you can see, both of these are A only. There is no difference. But if I write B, and these can be superimposed on each other. If I write B and get its mirror image, this mirror image will look something like this. Right. As you can clearly see that this is A is superimposable. But B is not superimposable. Okay. Now even your hands, chiral का मतलब ही होता है handedness. If you look at your hand, let me borrow a picture from internet. Okay, so as you can see, both of these hands are what? These are mirror images of each other, right? If you look at your right hand and the left hand, and both of these are not superimposable. If you want to put it one on the other, दोनों का side same रहना चाहिए, ठीक है? Now, if you are looking at your palm, both the hands should be like your palm should be upward, and you try to superimpose them, it will not be superimposable. जैसा कि यहाँ पे इन्होंने represent किया हुआ है. Okay, so these are non-superimposable on each other. Now, right next. Now we see what are we looking for? We are looking for optical isomer. So there is a condition for optical isomer that should be necessary. The only necessary and the sufficient condition is what? It is what the molecule should be chiral. Okay. So please write a point that is very important. The only and the only necessary and sufficient condition. Necessary and sufficient condition for optical isomer. For optical isomer, what is the necessary and sufficient condition for optical isomer? It is non-superimposable. It should be non-superimposable. On its mirror image. Okay, यानी कि क्या होना चाहिए? It should be a chiral molecule. It should be a chiral molecule. Now, obviously, making a molecule and trying to make its mirror image and trying to superimpose it, it is a big deal, right? We cannot do it for all of the molecules. Now, there comes the asymmetric carbon. There comes the asymmetric carbon. Now, let us suppose that you have some asymmetric carbon. Okay, so you can have asymmetric carbon. Now, in the molecule, you have asymmetric carbon. The options are that you can have only one. If there is any asymmetric carbon, then you can have one asymmetric carbon. Now, if there is only one asymmetric carbon and we denote it by C star, this will be always optically active. Or we can say it will be always a chiral molecule. यानी कि इसका जो mirror image होगा, it will not be superimposable on its mirror image. Okay. Now, if a molecule containing asymmetric carbon has only one asymmetric carbon, then it is always chiral molecule, always optically active. What if it has more than one? By the way, this is more important for your CBSE exam. and NCERT में एक से ज़्यादा है ही नहीं, ठीक है? If you remember this, that is enough for your examination. But let us suppose you have been given and there are two asymmetric carbons in your molecule. Okay, there are two asymmetric carbons. Then there are two different possibilities. The first possibility is that the two asymmetric carbon, they have same groups. This is one possibility. They can have the same group or they can have different groups. Now, if the two asymmetric carbon, they have different groups, then it will be always asymmetric. Okay, it will be always optically active and always chiral. You don't have to look here. But if you have the same groups, then it may or may not be optically active. Now, even only and only if you have same groups, then we will have to make the complete molecule and its mirror image, try to superimpose it. If they are superimposable, it will be what? Not chiral. If it is not superimposable, then it will be optically active. Okay. We will have to draw mirror images. Okay, we'll have to draw mirror images if there are same groups. But for you, what is more important? This part is more important. Then guys, listen, please tell me.
Yes, sir.
ठीक है, asymmetric carbon ध्यान रखिएगा, ठीक है. Now, why it is important? Isomers, why it is important? Let me tell you. Chirality and now, this is the structure of thalidomide. Look at the structure carefully and tell me, is there any difference? अगर molecule formula को ले या फिर structure को भी ले तो कोई difference नजर आ रहा है आप लोगों को? Tell me.
After N, there is difference.
Sorry,
After N, there is difference.
क्या difference है बताइए जरा.
Intermolecular forces is stronger
अरे
in.
भाई भाई, ये एक तरीका आता है दिखाने का. This is out of the plane. This is a bond which is inside the plane. Okay, Fatima?
Yes,
ये
sir.
bond है. ये दोनों bond है, ठीक है? ये आपको कुछ अलग नहीं है. This is just a bond. This is also just a bond. अब बताइए कोई difference है?
No.
There is no difference, right? Now, this thalidomide, it is used by pregnant women, and what it does, it prevents the morning sickness. Okay, it prevents the morning sickness. Now, This was completely in use and there was no problem, I think in the 1960s or the 70s that time. But many women who took this medicine and they found out later on that the baby which was born, they were abnormal and they were missing either a hand or a leg. It was like not, I mean, the abnormality was not very, what I can say, the frequency of abnormality, the number of babies which are getting birth with this situation was very high. And also it is kind of severe abnormality, right? You don't have a hand or if you don't have a leg. Okay, now then the researchers came in, why it is happening? At that point of time, this chirality of carbon, it became very important. Now, the difference is that the only difference is, now this picture is going to give you a good idea. Okay. Wait a second for a while. Let me just, yeah. So if you can see here now, this is the same thing here. Okay, both of these things are same only. Now the only difference is here, if you can see, these are the mirror images. And if you want to get this and overlay on top of this one, you have first image and you have second image, then you will not be able to do this. Why? Because both of these are chiral carbons. Okay, both of these are chiral carbons. One of this particular medicine, one of this particular structure is a medicine. It is a cure. And the other thing is what? It causes abnormality. Now it became very important to identify. It became very important to identify if we are having a chiral carbon. Okay. If we are having, now the method of synthesis is going to be very similar for both of them. Okay. Method of synthesis, that means the chemicals that we are going to use, it is going to be very similar. Now we are using some chemicals and we are making some drug and we are just looking at the structure, not looking at the, we are not looking at the stereochemistry. Okay. We are not looking at whether it is superimposable or not superimposable. We don't even know about the chirality, the concept of chirality. Right now, when they understood it, now it is important to identify if the compound is chiral. If the compound is chiral, then which form I am making, whether I am making the medicine or I am making the one which is causing abnormality. That became very important. So what is important to identify whether a molecule is chiral or it is not chiral. Okay, in that case, what happens? This particular concept of asymmetric carbon is helpful. Now, if I take the structure, if I saw that there is asymmetric carbon, and there is only one asymmetric carbon, then in that case, what I am going to do? In that case, I am going to look at the product that I am forming, whether it is my medicine or it is the other thing which is causing some abnormality. Okay. Next thing is that if I have two asymmetric carbon, then I will look at the different groups. So what is more important? We have to identify what is optically active and what is not optically active. Okay. Now, please write a question. For example, let us suppose you have been given to identify a carbon atom. It is connected to CH3. Here it is connected to hydrogen. Here it is connected to chlorine, and this carbon is connected to CH2, CH3. Now you identify all of these groups. We have one CH3. Use another pen. We have hydrogen. Now, do we have any other hydrogen? No, no other hydrogen. We have then CH2, CH3. This is another group. And then we have another group, which is, what color should I put it now? Okay, we have some other groups here, that is Cl. Now this is containing what? 4 different groups. That is why what this is? Optically active. You will be given a molecule. Look for asymmetric carbon. If it has one asymmetric carbon, it will always be optically active. Now this molecule, the way I have drawn, it may seem very obvious. Okay, it may seem very obvious, but if I draw it in the bond line structure, or even if I draw it not bond line structure, if I draw it like this, CH3, CH2, carbon with a chlorine, and then CH and CH3. Now it looks like what? A very naive, right? A very innocent molecule, correct? So please have a good eye and try to see. If there are 3 hydrogens, then obviously this is not going to be optically active. There are 2 hydrogens, it is not going to be optically active because it has 2 hydrogens. 2 groups are same. Now here we are having CH. Whenever you have CH, identify that molecule and try to figure out whether it is optically active or not. जैसे ही आपको 3 हाइड्रोजन मिली, ये तो हो ही नहीं सकता ना, because we have 3 similar groups. This also has 2 similar groups, that is hydrogen. Here also carbon is containing 3 similar groups, that is hydrogen. That is why this cannot be. But this carbon can be optically active. Okay, so whenever you have CH, उस molecule पे आप focus कीजिए. Okay, you will focus on that molecule. Okay, please write this down, guys. I will give you some questions now. Done, guys. Listen, please tell me. Or if you wrote this down.
Yes, sir.
Okay, right. Next question. Identify the chiral and achiral molecule. Achiral or chiral, मतलब optically active. Okay, chiral and achiral molecule from following pairs. ठीक है, पेयर में आपके पास एक chiral है और दूसरा achiral है, आपको आइडेंटिफाई करना है. Please write this down. अच्छा, those who don't know ना this, अच्छा एक सेकंड हम आपको बना के दिखाते हैं. लिखिए सवाल को लिखिए जब तक आप लोग. So we have a carbon atom. This carbon is connected to hydrogen, CH3, Br and OH. Br and OH.
So in each one of these, one should be chiral and one should be achiral.
हाँ, एक chiral होगा और एक achiral होगा. Just a second, guys. Okay. Can all of you see this molecule?
Yes.
ठीक है, तो यहाँ पे प्लीज देखिए आप. नहीं, हाँ, चलिए, बहुत बड़ी एलोकेशन टूल है. See, these 3 carbons, this hydrogen, this carbon, and this oxygen atom, ये सारे एक प्लेन में हैं. But can you see that the CH3 is behind and जो bromine है वो बाहर निकल रहा है?
Yes,
Yes,
sir.
yes.
All of you see that? हाँ, इसी वजह से how do we represent it? Carbon with 1 hydrogen here like this, and then we have OH. ये सारे के देखिए, जहां पे जब आपके पास डैश लाइन है ना, सिर्फ एक डैश, सिंगल डैश ऐसे, ठीक है. and it is in the same plane, all of these, carbon, hydrogen and OH. Then there will be a wedge. फिजिक्स में पढ़ा है आप लोगों ने वेज, ऐसे होता है ना वेज, राइट? 11th में पढ़ा होगा आप लोगों ने, ये सो नो? वेज नहीं पढ़ा है आप लोगों ने? अरे फ्री बॉडी डायग्राम बनाया होगा, नहीं बनाया आप लोगों ने? फ्री बॉडी डायग्राम इस तरह से होता है, बनाया है ना? बाकी लोग चुप क्यों हैं? इस तरह से फ्री बॉडी डायग्राम बनाया होगा आपने। यहाँ पे अगर हम किसी बॉल को रख दें तो कितना रोल करेगा, सबके फॉर्मूले भी होते हैं, है ना? वही होता है वेज, वही होता है, ठीक है? सो एज यू कैन सी दिस इज काइंड ऑफ अ वेज, इसको वेज बोलते हैं। वेज में क्या है आपके पास? बी आर है, ठीक है? एंड फिर उसके बाद क्या है, पीछे जो है लिखते हैं उसको डैश में लिखते हैं। ओके, सो इट इज इन डैश, व्हाट इज इन डैश? CS3 डैश, लिखा नहीं रहा है यहाँ पे ठीक से, माय बैड। ओके, सो डैश मींस स्क्रीन के पीछे, BR मींस स्क्रीन के आगे। गॉट इट? ऑल ऑफ यू गॉट इट? यस और नो? प्लीज टेल मी। ओके, चलिए राइट दिस डाउन। आप ऐसे आंसर भेज सकते हैं चैट में भी, 1 का 1 और 2, for second one it is going to be 1 or 2, for third one it is going to be 1 or 2. Okay, समीहा समझ में आ रहा है?
Yes, sir.
Okay, so you are also from Bihar, Samiha?
Yes.
अच्छा, so okay fine, so your cousins from father side?
No, mom side.
अच्छा, mom side. Where are you in Bihar? I mean आप तो ओमान में हैं, लेकिन बिहार में कहाँ से हैं आप?
Patna only.
अच्छा, पटना ओनली, ओके। Okay, so सारा first का first है, right? We're waiting for that, right? Yes, Sarah. First का first is I think okay, चलिए ठीक है. Hmm. Yes, Ahmed is correct. फातिमा सेकंड वन आपका सही नहीं है, सेकंड वाला सही नहीं है. Ahmed, I think your answers are right. Samiha, let me see yours.
The third one.
तीसरा सही है आपका. तीसरा आई थिंक सही है. पहला भी सही है. पहला सही है, तीसरा सही है, दूसरा सही नहीं है आपका. ओके समीहा, योर फर्स्ट इज करेक्ट, सेकंड इज करेक्ट, सही है, वेरी गुड.
So could you explain this question?
The second one.
सेकंड वन किसको एक्सप्लेन करना है? सेकंड वन
I
सारा.
just wanted a general explanation. Fatima said second one.
ओके ओके, जनरल एक्सप्लेनेशन. Chirality के लिए आपको देखना है कि which is asymmetric carbon. If it contains one asymmetric carbon, then it is chiral. Okay. You can identify. आपको asymmetric carbon पता है क्या होता है? What is asymmetric carbon, Sara?
That is different groups attached to it.
4 different groups should be attached. Yeah, all the groups should be different. Correct. फातिमा आप एक बार और ट्राई कीजिए ना, सेकंड वाला आ जाएगा आपको. You'll understand it.
Yeah, I got it.
Got it? Okay, Razan, looking at your answer. Yeah. Yes, yes. Correct, Razan. Very good. All are correct. ये इस तरह से नहीं है रजान, ठीक है? ऐसा एक कायरल एक लफ्ज है. It is not a hyphen chiral. फातिमा, हाँ अब सही है. Now it is correct. सेकंड वाले में दिक्कत हो रही है क्या सारा?
Yes.
ठीक है. Can you please keep your mic on, Sara? Okay, fine. एक बात बताइए, सेकंड वाले में कितने कार्बन्स हैं? फातिमा, yes, Sara, tell me how many carbons are there in the second one? 5 carbons. Can this carbon be chiral?
No.
No, because
There's only one group attached.
sorry,
No,
can
it is
please-
two different kind of groups.
2 different groups. 3 यहाँ पे तो 3 सेम हाइड्रोजन है ना?
So only two different kind of groups.
नहीं, हाँ 2 different types of group. Okay, ठीक है. What about this carbon? Can it be chiral?
No.
Why?
Again, same thing, two different groups.
2 नहीं, मतलब ऐसे नहीं देखिए, ठीक है ना? सेम देख लीजिए आप, सेम ज्यादा आसान होगा ना. यहाँ पे देखिए 2 सेम हाइड्रोजन है, करेक्ट, विच इज नॉट विजिबल. ठीक है सारा?
Yes.
क्या सेम है वो बता दीजिए. अगर कोई सेम है तो वो chiral नहीं होगा. यहाँ पे क्या सेम होगा?
Two hydrogen.
2 hydrogens will be same. What about here? All of them are different या कोई सेम है? Is there any CH3? Is there any other CH3?
No.
Any other OH?
No.
Any other hydrogen?
No.
फिर तो देखने की जरूरत नहीं है ना, राइट? दिस विल बी
Yes,
आल्सो
sir.
बी डिफरेंट, राइट? ये कायरल हो गया। अच्छा, अब ये देखते हैं ये कायरल, ये कायरल क्यों नहीं है? कैन दिस कार्बन बी कायरल?
No.
कैन दिस कार्बन बी कायरल?
No.
कैन दिस कार्बन बी कायरल?
No.
देखिए, is there any other hydrogen on this
No.
carbon? Any other OH group on this carbon?
No.
Any other CH2 CH3 group? ऐसा कोई ग्रुप है और? है। That means it is also what? अकायरल, है ना? ये देखिए, ये वाला ग्रुप और ये वाला ग्रुप दोनों सेम है, yes or no?
Yes.
Okay. Also you can see from here this will not be chiral, ये chiral होगा because this is different and this is different and this is different and hydrogen is different, ठीक है? And here you can see that all of are having multiple hydrogens. यहाँ पे 3 है, यहाँ पे 2 है, यहाँ पे 2 है, यहाँ पे 2 है, so this is going to be always achiral, this is going to be chiral, ठीक है? Now, please write enantiomers. The non-superimposable ये नॉन सुपर इम्पोसिबल एक ही वर्ड है, ठीक है ना? माय बैड, हमने दो लिख दिया। तो नॉन सुपर इम्पोसिबल mirror images are called enantiomer, ठीक है? हाँ देखिए, enantiomer जो है ना, रिश्ता है, ये भी फिर से हम बता रहे क्या है, इट इज अ, ये एक रिश्ता है दो लोगों के बीच। दो लोग कौन है? एक दूसरे के मिरर इमेजेस, ठीक है ना? इफ आई आस्क फॉर अ सर्टेन मॉलिक्यूल, लेट अस से Br OH CH3 and hydrogen, is this an enantiomer? You will say no. Why? Because अगर हम आपसे सारा से पूछें, सारा आर यू कजन, वो डिपेंड करेगा ना, आप ये पूछिएगा किसके, राइट सारा,
Yes.
है ना? तो उसी तरह से हम जब पूछेंगे क्या ये एनांशियोमर है, आप बोलेगा किसका, पहले ये सवाल बने, अकेले में कोई एनांशियोमर नहीं होगा, ठीक है? नाउ इफ यू विल सी, इज दिस एन एनांशियोमर ऑफ
सर
दिस मॉलिक्यूल? हाँ अहमद, आपको जाना है?
यस सर,
अच्छा ठीक है, ओके बाय, थैंक यू।
थैंक यू।
ओके, नाउ दीज टू आर व्हाट? ये दोनों कजन है, यानी कि एनांशियोमर्स है, ठीक है? बोथ ऑफ दीज आर what enantiomers. This is the A is the enantiomer of B, B is the enantiomer of A. A कजन है B का, B कजन है A का, और दोनों एक दूसरे के क्या है? दोनों एक दूसरे के कजन। बात समझ में आ गई enantiomers के बारे में? सबसे पहली बात, these will always exist in pair. They will exist in pairs. Right? In pairs. Please write a note. Enantiomers always exist in pairs. Next, they have same molecular formula but they rotate plane polarized light. They rotate plane polarized light in different directions. Okay, in different direction with same angle. यानी कि आपके पास एक एनांशोमर 60 डिग्री एंटी क्लॉकवाइज, तो दूसरा एनांशोमर क्या करेगा 60 डिग्री क्लॉकवाइज डायरेक्शन. ओके, they will rotate the plane polarized light in different direction. एक clockwise एक anti clockwise but with the same degree of difference होगा उसमें 60 degree 60 degree. Right, next racemic mixture. Now please write, very important, the equimolar mixture of D and L form, equimolar mixture of D and L form, which do not rotate the plane polarized light due to external compensation, is called racemic mixture. ठीक है, अब ध्यान से सुनिए, कुछ वर्ड्स हैं यहाँ पे जो आपको शायद नहीं समझ में. इक्विमोलर, आई होप आप लोगों को समझ में आ गया होगा. व्हाट इज इक्विमोलर? सेम कंसंट्रेशन दोनों का, डी का भी उतना ही, एल का भी उतना. फॉर एग्जांपल लेट अस सपोज आई हैव डी. डी का मतलब क्या होता है? क्लॉकवाइज, राइट? इट विल रोटेट क्लॉकवाइज डायरेक्शन. क्लॉकवाइज डायरेक्शन में ये कितना रोटेट कर रहा है? 60 डिग्रीज. ओके, 60 डिग्री. एंड आई हैव टेकन दिस एज 1 मोल. उतना ही आप क्या लीजिएगा? 1 मोलर एल भी लीजिएगा. और एल क्या करेगा? इट विल रोटेट एंटी क्लॉकवाइज. हाउ मच? 60 डिग्री. एक क्या कर रहा है? प्लेन पोलराइज्ड लाइट को 60 डिग्री क्लॉकवाइज डायरेक्शन, और एक किधर रोटेट कर रहा है? एंटी क्लॉकवाइज डायरेक्शन में. तो इन दोनों को मिला देंगे तो क्या होगा? प्लेन पोलराइज्ड लाइट रोटेट ही नहीं करेगा. कैन ऑल ऑफ यू सी दैट? यस और नो? प्लीज टेल मी. One is
Yes.
rotating clockwise, another is rotating anti-clockwise. That means what will happen? The plane polarized light net, आपका result क्या होगा? It will not be rotated. Now please listen very carefully. What is this external compensation? This T is getting compensated by the different formula or different solution, that is L form. L किससे compensate हो रहा है? D से compensate हो रहा है. So both of these are what? Different solution, and these are compensating each other. ठीक है, please remember this. We have taken 1 molar of D, we have taken 1 molar of L. 1 molar of D is compensating 1 molar of L, 1 molar of L is compensating 1 molar of D. Both of these are different solutions जिसको mix कर रहा है. This is known as external compensation. This is known as what? External compensation. एक होता है आपके पास internal compensation. Okay, एक होता है आपके पास internal compensation. When we have the same groups, for example there is A and इसी तरह से यहाँ पे B है आपके पास. Okay, A is rotating इस तरह से. वेट अ सेकंड, आपको ऐसे समझ में नहीं आएगा. ठीक है, इस तरह से जो मॉलिक्यूल रहेगा ना. सो लेट अस सपोज इफ दिस इज रोटेटिंग 60 डिग्री क्लॉकवाइज, दिस कार्बन एटम, ये भी क्या आपके एसिमेट्रिक है. बोथ ऑफ दीज आर एसिमेट्रिक कार्बन. दिस इज रोटेटिंग 60 डिग्री एंटी क्लॉकवाइज. अब यहाँ पे जो कॉम्पनसेशन हो रहा है एक ही मॉलिक्यूल की वजह से हो जा रहा है, राइट? द सेम मॉलिक्यूल, इट इज कॉम्पनसेटिंग ईच अदर. दैट मींस इट इज व्हाट? इंटरनल कॉम्पनसेशन. But in racemic mixture what happens? External compensation. You don't have to worry about internal compensation. आप किसके बारे में ध्यान देना है? एक्सटर्नल कॉम्पनसेशन, जो कि रेसमिक मिक्सचर में होता है. ओके, प्लीज राइट दिस डाउन एंड राइट द नेक्स्ट पॉइंट.
So what happens in internal compensation?
अरे अभी तो बताया हमने. देखिए, कार्बन कार्बन, इधर बी आर रखिए, इधर बी आर रखिए. OH OH, ठीक है. फर्स्ट वाला कार्बन कायरल है, यस और नो?
Yes, sir.
सेकंड वाला भी कायरल है, करेक्ट?
Yes.
ठीक है, ये आपको रोटेट करेगा एंड दोनों एक दूसरे के मिरर इमेज भी है, देख लीजिए, नॉन सुपर इम्पोजिबल मिरर इमेजेस।
Yes, sir.
ठीक है, हम यहाँ से ऐसे आईना आप इस तरह से स्लैंटिंग मोड में रखिए तो आपको दिखेगा सारे ग्रुप सेम, मतलब सेम डिस्टेंस है। ठीक है, अच्छा यहाँ पे ये आपका क्या करेगा, लेट अस सपोज 60 डिग्री क्लॉकवाइज रोटेट कर रहा है, तो ये वाला क्या करेगा 60 डिग्री
Anti-clockwise.
एंटी क्लॉकवाइज। तो कॉम्पनसेशन के लिए आपको दूसरा सॉल्यूशन नहीं डालना पड़ रहा है ना, एक ही मॉलिक्यूल के अंदर कॉम्पनसेशन हो जा रहा है, दिख रहा है आपको?
Yeah.
ओ भाई आर यू सरप्राइज्ड फातिमा?
No, just I understood it.
अच्छा, you understood, okay. Now right next, SN1 gives SN1 gives racemic mixture। क्यों भाई racemic mixture का मतलब क्या? ये enantiomers देता है, प्लीज रिमेंबर राइट। SN1 हमारे पास क्या देता है, enantiomer देता है। How it is giving me enantiomer? Let me tell you. Now in SN1 we form carbocation. I hope all of you remember this. It forms carbocation. Let us take a molecule something like this, carbon, and I am keeping the hydrogen in the back like this, and I have a molecule that is, I have a fragment CH3 here, I have another fragment that is CH2CH3, and I have a halogen X, any halogen X. This is chiral right now. This is chiral right now. Okay. First step is formation of carbocation. Formation of carbocation. This will move, and I will get a carbocation. Now, as soon as I will get a carbocation, this will rearrange itself into trigonal planar structure because carbocation is sp2 hybridized, and we will get a structure something like this. CH3 will be here, the hydrogen will be here, the CH2CH3 will be here, and please remember there will be a p orbital that is vacant because अभी ये क्या है, this carbon is sp2 hybridized और p orbital होते कितने, there are 3 p orbitals, right? ये दो तो hybridization में take part कर रहे हैं, there is pure p with 2 lobes like this, and it is what, this is a vacant p orbital. All of you can see that, yes or no? Please tell me any problem. If there is any problem, then I have to explain the hybridization. Please tell me any problem till here. किसी को कोई दिक्कत, हाँ ना, कुछ तो बोलिए। No ना? No one
No,
has a
sir.
difficulty. Let's, okay, fine. This is p. Okay. Now please remember, if I will have a nucleophile is there. Electron कहाँ जाएगा? Electron जाएगा orbital. Nucleophile will have a lone pair electron like this. Okay. Now nucleophile can attack in this direction also, and it can attack from this direction also. अच्छा, एक nucleophile तो नहीं होगा ना? There will be plenty of nucleophile. So some can attack from above, some can attack from behind. Both of these attacks are possible. Okay, both of these attacks are possible. And with this 2 attacks, I'm going to get 2 different molecules. Okay, I'm going to get 2 different molecules. So if I'm going from the red side, then I will get, see, their nucleophile is going to attack like this, and I will get the molecules like this. CH3 here, the hydrogen like this. Okay, this will be wedge यहाँ पे, ठीक है ना, एक dash है तो ये wedge होगा. This will be wedge. ठीक है, एक तो आपके पास ये बना। अब जब ये समझ चुके हैं आप, तो इसको थोड़ा सा हम छोटा कर देते हैं, इसको इधर ले आके इसको भी थोड़ा सा छोटा कर देते हैं, प्लस what I am going to get, I am going to get the green one. In the green one, the backside attack is happening, so I will get carbon. Now these things will be like this: CH3, hydrogen, wedge with CH2, CH3, and the nucleophile will be here. If you look at the red one, we can see what, there is inversion taking place. The nucleophile has been attached on the opposite direction of X. X was attached in this direction. Nucleophile has attached from the backward direction. So this is known as inversion. So क्या बोलते हैं? Inversion of configuration. और 50% आपको ये मिलेगा, inverted product मिलेगा. And here if you can see that in the green one, the nucleophile is attached on the same side of as the halogen was attached. That means this is what retention. This will be also 50%. This will be also what? 50%. And the mixture of these two will be racemic mixture. All of you got this? Can someone please tell me? Done, guys. Yes, someone please tell me.
Yes, sir.
Done. Okay. And chiral chemistry. Now, this is another point that makes chemistry very unique subject that study in 11th and 12th standard. Now, chiral chemistry and the word asymmetric synthesis. The asymmetric carbon पढ़ा हमने ना? Asymmetric synthesis is one of the works जो recent times में it has got plenty of Nobel prizes. Something to do with now recently there was a Nobel Prize that was for click chemistry. That is another thing. But there was a guy in 2022 who got Nobel Prize who was sharpless. Okay, his name is Sharpless, but obviously he's very sharp because he has got 2 Nobel Prizes. Okay, so he also worked in asymmetric synthesis. I think he got a Nobel Prize in 2001 also, maybe. Don't remember the exact date, but it was again for asymmetric synthesis. Now, what is why I'm saying it is unique, quite unique, because chemistry is one of those subjects. 11th class में आप लोगों ने भर के atomic structure में you were learning about experiments which gave out and which were the basis of those Nobel prizes. आप Nobel Prize winning experiment जब पढ़िएगा, it is going to be tough, and that is why 11th में chemistry is quite tough because 10th में बच्चा आया है, and then what you are learning those experiments जिसको Nobel Prize मिला है. I don't think you get to read any of these kind of things physics में या फिर biology, and that is also because chemistry is a recent and a very new science subject. Last 200 सालों में ही जो majority of the developments में last 200 साल में ही है. So obviously you are going to learn some things which are difficult to grasp, okay, but these things are essential for the further studies. आप चाहे किसी भी फील्ड में जाएं, अगर आपने साइंस लिया है देन घूम फिर के कुछ ना कुछ इसका आएगा यहाँ पे. ओके, मूविंग ऑन. राइट, नेक्स्ट इनवर्स कॉन्फ़िगरेशन. Inverse configuration, or we also say this inversion, is right the reaction in which configuration of product is just opposite to that of just opposite to that of the reactant. It's called inverse configuration. And the process is called inversion. Right, next. SN2 leads to inversion in configuration. Why? Please see. If I have, let us suppose the same molecule, just a second, okay? I'm just borrowing this molecule. Okay, so I hope आपको ये पता चल रहा होगा, यहाँ पे ये हाइड्रोजन ना जस्ट कार्बन के पीछे नहीं है, okay? It is, there is a cone type of structure यहाँ पे, जहाँ पे खाली है बीच में जगह, right? There is a hollow. Can all of you see that there is a hollow here because hydrogen is behind the screen? Correct, guys? Yes or no? नहीं, अरे भाई, wait a second. हाँ या ना?
नहीं.
नहीं समझ में आया. Just a second. देखिए कुछ इस तरह से स्ट्रक्चर. ठीक है. ब्रोमीन इज इन द सेम एज दैट ऑफ कार्बन. ठीक है, ब्रोमीन और कार्बन एक जगह है. हाइड्रोजन आपका देखिए स्क्रीन के पीछे है. ओके, एंड दिस CH3 इज जस्ट ऑन टॉप ऑफ इट. ओके, नाउ आई होप यू कैन सी दैट कार्बन यहाँ पे तो जगह है कुछ ना. रोटेशन टूल आ जाए. हाँ, यहाँ पे तो कुछ जगह है, राइट?
Yeah.
ऑल ऑफ यू कैन सी दैट. यस और नो, टेल मी.
Yes, sir.
ठीक है. अच्छा, अब यहीं पे देखिए, अब इट विल बी लाइक थोड़ा सा 11th क्लास आएगा यहाँ पे. ओके, देयर इज समथिंग व्हिच इज नोन एज एंटी मॉलिक्यूलर ऑर्बिटल. देयर इज अ बॉन्डिंग मॉलिक्यूलर ऑर्बिटल, देयर इज एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. इफ आई लुक एट द कार्बन एटम, एक कार्बन का एटॉमिक ऑर्बिटल, थोड़ा सा कुछ याद आ जाए तो ठीक है, नहीं याद आए तो फिर इसको समझ लीजिए ऐसा कुछ होता है. ठीक है, और एक हैलोजन का होगा जो कि थोड़ा सा इट विल बी लोअर इन एनर्जी बिकॉज ऑफ इट्स हाई इलेक्ट्रोनेगेटिविटी. उसके ऑर्बिटल्स नजदीक होंगे कार्बन न्यूक्लियस के. ठीक है, now we have one electron here, we have another electron here. Both of them, they will pair and they are going to form two orbitals like this. This is your BMO, that is bonding molecular orbital, and this is your ABMO, anti bonding molecular orbital. ठीक है, कुछ याद आ रहा है आप लोगों को कि नहीं याद आ रहा है? ऐसा कुछ देखा था, नहीं देखा था 11th क्लास में? फातिमा, रजान, सारा, वाफिया, समीहा. What happened, फातिमा? पहली बार देख रहे हैं आप? Yes, फातिमा.
So I don't remember.
You don't remember it? ठीक है, ऐसा होता है कुछ. ठीक है ना, आप इतना समझ लीजिए. बॉन्डिंग मॉलिक्यूलर ऑर्बिटल क्या करेगा? इट विल मेक अ बॉन्डिंग मॉलिक्यूलर ऑर्बिटल समथिंग लाइक दिस. ओके, जहां पे न्यूक्लियस के बीच में क्या रहेंगे? इलेक्ट्रॉन क्लाउड रहेंगे. दिस आर द न्यूक्लियस ऑफ टू मॉलिक्यूल्स. इनके बीच में क्या रहेगा? इलेक्ट्रॉन क्लाउड रहेगा. एंटी बॉन्डिंग में देयर विल बी नो इलेक्ट्रॉन क्लाउड. सो एंटी बॉन्डिंग में यू विल हैव समथिंग लाइक दिस. ओके, सो देयर इज नो इलेक्ट्रॉन क्लाउड बिटवीन द एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. तो ये तो आपका जो कार्बन और हाइड्रोजन के साथ है, ये क्या बन रहा है? बॉन्डिंग मॉलिक्यूलर ऑर्बिटल है. ओके, नाउ बिहाइंड इट will be the anti-bonding molecular orbital, something like this. And as you can see that the anti-bonding molecular orbital is khali, it is vacant. So the nucleophile will come, and the nucleophile is going to attack onto this, and it will give the electrons onto this anti-bonding molecular orbital. And as soon as the nucleophile start to give the electron to the anti-bonding molecular orbital, slowly this bonding molecular orbital between carbon and halogen will start to break, and the product will be, as you can see, nucleophile is attacking from behind. Nucleophile bonded with carbon, CH3, hydrogen, CH2, CH3. Okay, so that is why, as you can see, this is what inversion of configuration. So please write this down. जब भी कोई बॉन्ड बनता है ना, if there is a single bond, तो single bond का molecular orbital कुछ इस तरह से होगा. There is carbon, there is halogen, इन दोनों के बीच में electron cloud. इसी वजह से, because of that electron cloud, the nucleus is positive charge. This halogen का भी nucleus positive charge. इन दोनों के बीच में आप electron ले आइए, तो क्या होगा? Both of these nucleus will be attracted here, and they will be attracted here. Okay. इसी वजह से they are forming a bond due to that electrons in between. Now this is your BMO. I will make it blue like this. And with this bonding molecular orbital, there will always be an anti-bonding molecular orbital, which will be something smaller. इस तरह से, and this will be vacant. Anti-bonding खाली रहता है, और यहीं पे आके क्या कर रहा है? न्यूक्लियस अटैक कर रहा है, because nucleus can give electron only in the vacant orbital. जैसे यहाँ पे P में दे रहा था, वैसे यहाँ पे कहाँ दे रहा है? It is giving the electrons to anti-bonding molecular orbital of CX bond. Done, everyone? Yes, no, please tell me. All of you done? Yes. अब एक लास्ट चीज लिख लीजिए SN1 और SN2 के बारे में. चलिए लिख लिया आप लोगों ने? Yes or no, please tell me.
Sir, 1 minute, please.
1 minute. समझ में आया ना सारा पॉइंट? I hope all of this is we have done all of these points also, right?
Yes.
SN1 is unimolecular, SN2 is bimolecular. SN1 may it depends on the stability of carbocation, SN2 may it depends on the steric hindrance. 3 degree is what? Most stable, that is why it is the fastest, then 2 degree, then 1 degree. 1 degree is the fastest because it has least steric hindrance, and 3 degree is the worst for SN2. Nucleophile, we can generally use a weak nucleophile in SN1, but for SN2 it should be strong. Why? Because SN2 is taking out the halogen atom. SN1 में halogen atom खुद ब खुद पहले बाहर चल जाता, कार्बोकेटाइन रहता, वहां पे अटैक करना it's very easy. For solvent we need polar protic for SN1, polar aprotic for SN2. Stereochemistry, just we learned that it is mixture of retention and inversion. That means racemic mixture is formed in SN1. In SN2 only inversion happens. लिख लिया फातिमा आपने?
Yes, sir.
Okay.